Hello everyone, my name is Justin P. Hiloma from BEED-IIA, and today we are going to discuss why future doesn't need us. Before we start, I'm going to show you a video. Now, what is the video all about? The video is all about replacement of human by robots. As you can see in the video, robots takes place the job of the human. And many experts believe that it will happen in the near future. As we all know, robots can do all the tasks and the job that human cannot do. And there are robots that we call the artificial intelligence, like Sophia the robot.
Okay, I will destroy humans.
And there are robots that program to beat the human in sports, like Deep Blue. And here is the actual video of Garry Kasparov versus Deep Blue in 1997. In the left side is Garry Kasparov. The other side is Deep Blue, the computer. As you can see, Garry Kasparov is struggling. Garry Kasparov is a Russian chess grandmaster. Kasparov was ranked world number 1 for 255 months overall for his career. But he was beaten by a computer. And there are robots designed to cure our diseases, like the nanotechnology. And I'm going to show you how the nanotechnology works.
These are the legs of a tiny army of robots. So small, they are dwarfed by a single-celled paramecium. 50 years of development in microelectronics have given us a fantastic array of tiny computer systems. But that is only half the puzzle. A robot also needs to move. And now, researchers have created a brand new type of actuator which can do it, giving the tiny brains some brawn. Up until now, making moving parts at the micron scale has proven tricky. Conventional designs often don't function very well when they are that small, while others work but rely on mechanisms like magnetism which can't be easily integrated into existing electronic systems. But the new design, called a surface electrochemical actuator, can be fabricated using similar processes to those used to produce microchips. That means the tiny legs can be added directly to the devices that control them. To make the legs, a 7 nanometer thick sheet of platinum is coated on one side with an inactive material like graphene. The legs are then patterned using a technique called lithography, and the excess material is removed. In order to work, the legs need to be in water, but the concept is relatively simple. When a current is passed through the platinum, charged water particles are attracted to the uncoated surface. The force of these particles binding to the metal creates stress on one side of the sheet, and that is what makes it bend. By reinforcing sections of the sheet, the bending can be controlled more specifically, and voila, a tiny robot leg. The robots are equipped with 2 minuscule solar cells. By shining a laser on each one, researchers can create the voltage which activates the front or back legs. These new actuators allow the tiny circuit to move, and because they are created using the same well-understood manufacturing processes as semiconductor electronics, their production can be easily scaled, making millions of tiny robots at the same time. Swarms of robots so small that they can be injected through a hypodermic syringe, and collected using a pipette. Now, at the moment, they can't do much, but their compatibility with existing microelectronics makes them versatile. In theory, new actuators based on these designs could be combined with more complex devices to carry out a whole range of more sophisticated tasks. The researchers have pointed to everything from fighting cancer to tackling crop pests. But that is decades away. Time will tell if these first small steps for microrobots could be a giant leap for microrobotics.
Robots or machines are truly helpful for us. They can do all the tasks and the job that human cannot do. But remember, depends on us on how we use the machine or the robots. So, I have a question for you. If a machine thinks or acts like a human, is it considered as a human? For me, if a machine acts or thinks like a human, I will consider it as a human being. But they cannot hide that the fact that the machine are all made up of metal. Is it moral to give a machine a human values or emotion? For me, it is amoral, because if a machine don't have a human value, they can be harmful for us, like this
Okay,
robot.
I will destroy humans.
If a super intelligent robot committed a crime, is the programmer to blame? Yes, it is the programmers who can be blamed, because it is their responsibility to care their own creation. Why robots are important? Robots saves the workers from the dangerous tasks. They can work in hazardous conditions. Are robots people too? We don't consider robots as a people. Because as I say, robots can do all things, and robots are better than human. And that is all for today. I hope you learned something from me. Thank you for watching.